Hello there, and welcome to Epoch History for Sleep, where gentle curiosity meets the profound depths of science and wonder is allowed to unfold at its own pace. Tonight, we're not going to discuss how the universe began or where it's ultimately heading. Instead, we're going to look beneath our own feet and ask something rather unsettling, something elegantly simple, yet not easy to answer. What if we're not the first? Not the first thinkers, builders, explorers to call this planet home? What if long before pyramids and satellites and bedtime science channels, another civilization lived here on Earth, rose to something remarkably complex, and then vanished without a trace? I don't mean mythical lost continents or alien visitors. I mean an actual civilization, something homegrown, biological, intelligent, perhaps in ways we don't fully comprehend. Something that lived and thrived and died so long ago that the planet itself may have completely forgotten their existence. If that sounds like the setup to a science fiction tale, well, it sort of is, but it's also a genuinely serious scientific question, one that's been quietly circulating around geology labs and cosmology conferences for years now. The idea isn't that we'll discover skyscrapers buried under Antarctica or smartphones embedded in ancient coal seams. It's far more subtle than that, more whispered than proclaimed. Before we venture deeper into this mystery together, I'm curious, what time is it where you are right now? Are you settling in for a peaceful sleep? Or perhaps it's morning where you are, and you're starting your day with this peculiar question. The question is this: if there had been an advanced civilization millions of years ago, could we even tell today? Would any traces survive the slow, relentless grinding of Earth's geological processes? Or would everything, cities, tools, languages, even bones, have been recycled back into rock and soil, rendered completely indistinguishable from nature itself? Funny, isn't it? The topic is ancient, vanished civilizations, and yet here we are, separated by countless seconds and miles, quietly sharing this same little moment in time. Drop a comment below and let me know where in the world you're listening from tonight. No matter where or when you are in this vast world, I'm genuinely glad you're here with us. Before we begin to explore what might be hidden beneath the accumulated layers of deep time, if this kind of slow-burning, contemplative question draws you in the way it draws me, I'd be deeply thankful if you tapped like or subscribed. It truly helps this sleepy little signal reach other curious, wondering minds out there in the darkness. No pressure, of course, just a gentle invitation, like the faint trail of footprints that might, if we look closely enough, lead somewhere completely unexpected. So settle in comfortably, maybe lie back if you can, and let your thoughts slow down to match the patient pace of plate tectonics themselves. We're going to take a long, careful look backward, not through recorded human history, but through the crust and silence and accumulated heat of deep time itself. Because before we can meaningfully ask whether someone came before us, we have to understand just how much time we're actually dealing with, and how remarkably good this planet is at wiping the slate completely clean. When we talk about ancient history, we usually mean a few thousand years. The pharaohs of Egypt, the mysterious builders of Stonehenge, the earliest known scripts carefully etched into clay tablets. Even when we reach back to the very dawn of human civilization, we're still only going back about 10 or 12,000 years at most. That's literally a blink in geological time. It's closer to now than to almost anything else that's ever happened on this ancient planet. And yet to us, it already feels like the deep, mysterious past, already enough to fill entire libraries with mystery, debate, and endless speculation. But the Earth is genuinely old, staggeringly, almost incomprehensibly old, not just millions of years old, but billions, about 4.5 billion years, give or take a few hundred million. For the vast majority of that immense span of time, there were no humans whatsoever. There weren't even mammals for most of it. And for much of it, there was no complex life on land at all. Life spent enormous amounts of time swimming, or waiting, or evolving in microscopic obscurity, invisible to any observer who might have been watching. And yet, despite how empty and barren that might sound, this was precisely when most of Earth's true story was being written. Layer by painstaking layer, rock by accumulated rock, in forms that speak slowly and forget quickly. The planet doesn't keep a detailed diary. It doesn't preserve everything equally or fairly. Wood decays, metal rusts and crumbles, bones dissolve into nothing, and time doesn't just pass, it actively acts. It buries, melts, crushes, shifts, and systematically erases. Mountains rise proudly and then crumble into dust. Oceans open and close like breathing. Entire continents drift, collide violently, and break apart. Every few 100 million years, the entire face of the world changes completely and utterly. And when you truly look at it this way, it's not that evidence simply gets lost. It's that surviving anything at all for more than a few million years is already an extraordinary, almost miraculous event. The preservation of even the hardest, most durable materials becomes a cosmic lottery where the odds are heavily stacked against permanence, where pure chance and random circumstance matter far more than durability or historical importance. So let's imagine, just as a thought experiment, just for a moment, what if, say, 100 million years ago, long after the age of the dinosaurs had begun, but long before it would end, an intelligent species somehow evolved, something upright, or perhaps not, maybe land-based, maybe aquatic, maybe something entirely different. Maybe it didn't build with familiar stone or metal at all. Maybe it never needed to. Maybe it had technology of a kind we wouldn't even recognize today, woven from biology itself, grown rather than forged, cultivated rather than constructed. Maybe it lived for a considerable while, developed something we might even call culture or sophisticated society, and then something happened. A gradual shift, a sudden catastrophe, or simply the slow, inevitable fade of time itself. It disappeared completely. When we talk about ancient history, we usually mean a few thousand years. The pharaohs of Egypt, the mysterious builders of Stonehenge, the earliest known scripts carefully etched into clay tablets. Even when we reach back to the very dawn of human civilization, we're still only going back about 10 or 12,000 years at most. That's literally a blink in geological time. It's closer to now than to almost anything else that's ever happened on this ancient planet. And yet to us it already feels like the deep, mysterious past, already enough to fill entire libraries with mystery, debate, and endless speculation. But the Earth is genuinely old. Staggeringly, almost incomprehensibly old. Not just millions of years old, but billions. About 4.5 billion years, give or take a few 100 million. For the vast majority of that immense span of time, there were no humans whatsoever. There weren't even mammals for most of it. And for much of it, there was no complex life on land at all. Life spent enormous amounts of time swimming, or waiting, or evolving in microscopic obscurity, invisible to any observer who might have been watching. And yet, despite how empty and barren that might sound, this was precisely when most of Earth's true story was being written. Layer by painstaking layer, rock by accumulated rock, in forms that speak slowly and forget quickly. The planet doesn't keep a detailed diary. It doesn't preserve everything equally or fairly. Wood decays, metal rusts and crumbles, bones dissolve into nothing, and time doesn't just pass, it actively acts. It buries, melts, crushes, shifts, and systematically erases. Mountains rise proudly and then crumble into dust. Oceans open and close like breathing. Entire continents drift, collide violently, and break apart. Every few 100 million years, the entire face of the world changes completely and utterly. And when you truly look at it this way, it's not that evidence simply gets lost. It's that surviving anything at all for more than a few million years is already an extraordinary, almost miraculous event. The preservation of even the hardest, most durable materials becomes a cosmic lottery where the odds are heavily stacked against permanence, where pure chance and random circumstance matter far more than durability or historical importance. So let's imagine, just as a thought experiment, just for a moment, what if, say, 100 million years ago, long after the age of the dinosaurs had begun, but long before it would end, an intelligent species somehow evolved, something upright, or perhaps not, maybe land-based, maybe aquatic, maybe something entirely different. Maybe it didn't build with familiar stone or metal at all. Maybe it never needed to. Maybe it had technology of a kind we wouldn't even recognize today, woven from biology itself, grown rather than forged, cultivated rather than constructed. Maybe it lived for a considerable while, developed something we might even call culture or sophisticated society, and then something happened, a gradual shift, a sudden catastrophe, or simply the slow, inevitable fade of time itself. It disappeared completely, and now we arrive millions upon millions of years later, earnestly asking whether we'd even know if it had been here. Because here's the hard, uncomfortable truth: we're not nearly as permanent as we like to think we are. Our towering skyscrapers, our endless highways, our vast libraries and orbiting satellites, none of them are built to survive geological timescales. Leave a modern city completely alone for just a few centuries, and nature will reclaim it entirely. A few thousand years, and it's already becoming hard to see what was once there. But a few million years. Erosion, tectonics, subduction. By then, the entire surface has fundamentally changed. What was once dry land might now be deep seafloor. What was once a mighty mountain might be scattered rubble, and most of our carefully constructed traces would be completely gone. This isn't science fiction or wild speculation. It's based solidly on what we know from geology and archaeology. Traces of even relatively recent prehistoric human activity are incredibly rare and precious, not because humans didn't accomplish anything significant, but because Earth is a remarkably efficient recycler, a planetary composting system that turns complexity back into elegant simplicity with patient, inexorable, almost artistic thoroughness. Consider the fossil record for a moment. It's spotty at absolute best. Not because ancient life wasn't abundant, it was, but because the specific conditions required for fossilization are extremely particular and rare. Most organisms that die are never fossilized at all. They decompose naturally. They get eaten by scavengers. They dissolve into component elements. To become a fossil, you need rapid burial, precise mineral replacement, and protection from erosion over vast time periods. And then you need to get extraordinarily lucky enough for that rock to survive geological upheaval, get exposed to the surface again, and actually be found by someone who recognizes its significance. Multiply that challenge by tens of millions of years, and you start to truly see the staggering scale of the problem we're contemplating. And it's not just bones and organic remains. Buildings, artifacts, tools, even those made of supposedly durable metal, don't last forever in geological time. Most metals corrode and oxidize. Most plastics break down completely, especially when exposed to sunlight or buried underground. Even concrete, if left unprotected and unmaintained, eventually crumbles into unrecognizable fragments. So, if a sophisticated civilization had existed in the distant past, especially one that didn't leave behind vast quantities of massive stone structures, we might never know they were here at all. You might be wondering at this point, Has anyone ever seriously considered this possibility? And the answer is definitively yes. In 2018, two respected scientists, Gavin Schmidt and Adam Frank, published a fascinating paper exploring this very idea in careful detail. They weren't boldly proposing that such a civilization actually existed, but they were methodically asking how you'd even detect it if it had. They called it the Saluran hypothesis, named somewhat cheekily after a fictional race of intelligent reptiles from a classic British sci-fi show. Their real question was more methodological and scientific. What kinds of traces would an industrial civilization realistically leave in the geologic record after millions of years had passed? And could such traces already be there in the rock record, misinterpreted as something entirely different? They focused on subtle markers, chemical signatures, anomalies, things like carbon isotope ratios, unusual concentrations of rare elements, synthetic molecules that don't occur naturally anywhere on Earth. In other words, they were thinking like careful forensic detectives who can't find a body, a weapon, or a witness, but are hoping the environmental evidence might still tell a coherent story. And in doing so, they raised a genuinely uncomfortable possibility that challenges our assumptions. Maybe the absence of obvious evidence isn't actually evidence of absence. Maybe it's just how things naturally look when a geologically active planet resets its surface every few 100 million years with mechanical regularity. Because civilizations don't just vanish cleanly and completely, they inevitably leave waste behind them. Energy use, agriculture, mining, manufacturing, all of these activities leave distinctive fingerprints in the environment. But fingerprints fade over time, and if a previous civilization had gone through its own industrial age, or something functionally equivalent, would we still be able to see the lingering effects in climate records, sediment cores, or the chemical composition of ancient rocks? Maybe we would, maybe we wouldn't. I'm curious, as you're listening to this right now, are you the type of person who finds these deep-time questions genuinely fascinating or slightly unsettling? There's something both profoundly humbling and slightly vertiginous about imagining intelligence arising and disappearing across such vast, almost incomprehensible spans of time. If you're enjoying this journey into uncertainty and wonder, I'd love to know in the comments below. What specifically draws you to these kinds of questions about our place in the grand timeline of existence? Even now, at this very moment, our own civilization's impact on the planet is being actively written into the geological record for future scientists to discover. This is sometimes called the Anthropocene, the proposed name for a new geological epoch marked specifically by human influence on Earth's systems. Plastic accumulating in the oceans, concrete mixed into the soil, excess nitrogen in the atmosphere, radioactive isotopes scattered by nuclear tests. If future scientists, whoever or whatever they might be, dig into our present geological moment, they would almost certainly find these distinctive markers embedded in the rock. The critical question is, how long would those markers actually last? And how clearly visible would they be if millions of years passed before anyone thought to look for them? This isn't just idle speculation or science fiction dreaming. Thinking this way actually helps scientists test and understand the real limits of their investigative methods. It's about understanding not just what we successfully find, but what we're statistically likely to miss entirely. The geological record is notoriously full of significant gaps. Some periods are remarkably well preserved in exquisite detail. Others are almost entirely erased, as if they never happened. Erosion can completely remove layers of sediment that took millions of patient years to slowly build up. Tectonic activity can fold, fault, and bury entire regions so thoroughly they become inaccessible. And then there's the ocean, which covers more than 70% of the planet's surface and hides countless secrets beneath miles of water and accumulated sediment. Most of the Earth's surface is actually geologically young, relatively speaking. That is, it's been resurfaced or significantly altered within just the last few 100 million years. Even the ocean floor gets systematically recycled through a process called subduction. Old seafloor gets pushed under continental plates and melted back into the mantle, erasing whatever might have been there. That means if an ancient civilization had built anything near the coast, or on an island, or worse, in a now submerged region, those traces might be completely gone, consumed by the Earth's own internal recycling system. And yet we're here now, building, recording, observing with unprecedented detail. We wonder whether we're alone in the universe, sending signals to distant stars, but rarely ask if we've ever truly been alone on this very planet. Maybe the past was quieter than we think, or maybe we've just lost the ability to hear its whispered voices. We'll pick that up shortly, as we look more closely at what could possibly survive deep time, what couldn't, and whether we've already stumbled across traces without realizing their true significance. There's more to this story, more layers, both literal and scientific, and we'll keep moving gently through them, one careful step at a time. All right, let's slow down even more and ask something truly basic. Before we go looking for lost civilizations, we should probably decide what we're even looking for in the first place. What exactly constitutes a civilization, and what would make one count as significant, scientifically speaking? In everyday conversation, we tend to think of civilization as simply a kind of upgraded version of basic society. Cities, writing, governments, maybe an impressive skyline, but that's actually a very narrow, very modern view that reflects our own cultural biases. Even in documented human history, civilizations have looked wildly different from each other. Some built vast cities with monuments and elaborate road systems. Others left almost nothing behind but sophisticated language and careful land use patterns. And yet we'd still properly call them civilizations, recognizing their complexity and achievements. In archaeology and anthropology, the definition becomes considerably more careful and nuanced. Civilizations are usually identified by a characteristic set of traits: urban centers, specialized labor, centralized authority or governance, surplus agriculture, organized religion, social stratification, the development of writing or symbolic communication, and long-distance trade networks. Those are the major ones that scholars look for. But not all civilizations tick all the boxes neatly, and some accomplish these things in ways we might not immediately expect or recognize. So when we talk about the intriguing possibility of a forgotten or deeply ancient civilization, we need to broaden our thinking considerably. We're not necessarily looking for giant pyramids or computer chips buried in ancient rock. We're looking for evidence of genuine complexity, social, technological, or ecological things that don't happen by pure accident. Things that strongly suggest a group of beings organized themselves at significant scale over extended time for purposes that went well beyond simple survival. It's helpful to think about civilization less as a specific finish line and more as a broad spectrum of possibilities. Somewhere between isolated survival and full planetary engineering, there's actually a lot of room for variation, a culture of sophisticated tool users that created structures or systems extending beyond individual lifespans, a species that learned to systematically store knowledge, pass it on reliably, and modify its environment deliberately and sustainably. That might not sound like much at first, but it's absolutely huge in evolutionary terms. And if it happened more than once on this planet, or anywhere else in the universe, it's definitely worth taking seriously. Let's look at a concrete example closer to home. Take the ancient city of Çatalhöyük in modern-day Turkey. It's approximately 9,000 years old. No recognizable streets, No grand monuments, no written language that we know of, just densely packed homes built side by side with no ground-level doors. People entered through openings in the roofs, yet it's considered one of the earliest known urban settlements, a genuine city. Because what matters isn't the skyline or architectural grandeur, it's the underlying pattern. Coordinated building over time, long-term settlement, shared rituals, food production systems, burial customs. Even without grand architecture, it's a clear sign of collective behavior spanning generations. Go back further in time, and the clues become even more subtle and harder to interpret. The earliest evidence of symbolic thinking in humans comes from tools, pigments, carvings, things that imply planning, memory, perhaps even belief systems. Not technology in the modern sense, but still technological in its own historical context. Evidence that minds were working in abstract ways, thinking beyond immediate needs. So now imagine a civilization that existed not 10,000 years ago, but 10 million or 100 million years in the past. What would we realistically expect to find? It depends enormously on what they were like as a species and culture. If they built primarily with organic materials, wood, plant fiber, animal products, those materials simply wouldn't last in geological time. If they buried their dead with elaborate rituals, but not with durable artifacts, we might find bones but completely miss the cultural meaning. And if they never developed writing, or used a form we don't recognize as writing, their stories and knowledge might be lost completely and forever. Worse still, if they didn't live on land, or spent most of their lives in environments that don't preserve fossils well, our chances of detecting them shrink even further towards zero. If a civilization arose in a rainforest, on a coastline, or in a swamp, most of its remains would be gone within a few centuries, let alone millions of years. It's not a matter of deliberate hiding, it's simply a matter of time and environment working against preservation. We also have to be extremely careful not to project too much of our own experience onto this question. We're used to seeing intelligence in the particular form we exhibit: language, tools, cities, and now digital technology. But intelligence doesn't have to look like us at all. A civilization might not be industrial in any sense we'd recognize. It might organize its society in ways that don't leave big material traces. It might communicate chemically or visually or through forms of behavior we don't even have words for yet. And that brings up a genuinely strange problem. Would we even recognize it as a civilization if we found evidence of it? Think of a termite mound for a moment. To us, it's just a nest, a big pile of dirt and organic matter. But in terms of actual engineering, it's a genuine marvel. Internal climate control, sophisticated air circulation, resource storage, waste management. The termites build collectively across generations. They farm fungus. Their colony behaves as a single, coordinated organism. If we didn't know what we were looking at, we might easily mistake it for a purely natural structure. Scale it up by a factor of 1,000, or bury it for a few million years, and even that trace might disappear entirely into the geological background. So when we think seriously about lost civilizations, we need to think like both archaeologists and biologists simultaneously. We're not just looking for ruins or obvious artifacts. We're looking for patterns, anomalies, disruptions, unexpected concentrations of minerals, changes in sediment that don't match known natural processes, strange isotope ratios, things that might suggest someone or something was here doing something genuinely unusual. There's also the crucial question of duration. How long would a civilization have to exist to leave a detectable mark in the geological record? Not very long, geologically speaking. Humans have transformed the entire planet in just a few hundred years of intensive industrial activity. In terms of sediment accumulation, that's barely a dusting, but the chemical impact is already measurable and distinctive. Greenhouse gases, synthetic compounds, nuclear isotopes. Even if we vanished tomorrow, some of those changes would still be detectable for tens of thousands, maybe millions of years. So maybe the better question isn't simply whether a previous civilization existed, but whether we're even asking the right questions to detect it properly. We look for signs that make sense to us: fossils, ruins, tools. But what if the signs are stranger, smaller, or in places we haven't thought to look yet? What if they're written in languages we haven't learned to read? Do you ever wonder about this kind of thing in your daily life? When you're walking through a forest or along a beach, do you ever look at the rocks and soil and wonder what stories they might be holding? I'd love to hear your thoughts on this. Drop a comment and let me know if these questions spark your imagination the way they do mine. We'll keep going, because to answer this question fully, we need to look at how the Earth behaves over truly long spans of time, not just centuries or millennia, but entire epochs. And that means looking at the forces that erase what stays, what fades, and why. If you want to hide something forever, you don't need to bury it deep or burn it up. You just need to leave it on the surface of the Earth and wait, not days or decades, but long enough for geology to do its patient, inexorable work. Because the Earth is not still. It breathes, it shifts, it consumes, and almost everything built on top of it eventually disappears into its vast, slow-moving systems. We don't notice this much in everyday life. We tend to think of landscapes as permanent fixtures. Mountains seem eternal and unchanging. Rivers always seem to be in the same place. Cities feel like they've always been where they are, but geologists see something entirely different. They see motion in what looks solid. Over enough time, even the hardest rock flows, bends, or breaks apart. Even the tallest peaks crumble into sand and dust. The surface of the Earth is constantly being reworked by forces we can barely perceive. And that means anything resting on that surface is temporary by default, regardless of how permanent it seems to us. Start with weathering, the slow, patient work of breaking things down. Rain, wind, frost, heat, all of it slowly chips away at anything exposed to the elements. Cliffs erode grain by grain. Plant roots push through concrete with surprising force. Metals oxidize and rust. Organic matter rots and decomposes. And it doesn't take long for impressive buildings to become romantic ruins, and then for ruins to become barely distinguishable piles of debris scattered across the landscape. And if those remains aren't preserved under special conditions, rapid burial, arid climate, deep freezing, they're as good as gone in geological terms. Then there's sedimentation, the gradual accumulation of material, soil, sand, dust, ash. All of it builds up over time, layer by careful layer, burying whatever's underneath. Sometimes this helps preserve artifacts or fossils by protecting them from further weathering, but it can also crush and distort them beyond recognition. Layers compress into solid rock, organic materials get broken down or replaced by minerals, and after a few million years, that buried city or skeleton might be just a vague imprint in a chunk of limestone, if it's detectable at all. Tectonic activity is another key player in this vast game of geological recycling. The Earth's outer shell isn't one solid surface. It's actually a complex patchwork of plates that float on a slow-moving sea of molten rock deep below. These plates collide, pull apart, and slide past each other in a dance that's been going on for billions of years. When they interact, they create earthquakes, raise mountain ranges, open new seafloors, and drag old ones back into the mantle to be recycled. This last process, subduction, is especially important for our question. It means that entire sections of the ocean floor are gradually pulled under continents and recycled back into the Earth's interior. Whatever was on them, sediment, fossils, cities, melts and becomes part of the Earth's deep interior, not buried, but actually erased from existence. The average age of the ocean floor is only about 200 million years, which sounds incredibly old until you remember the Earth is over 4.5 billion years old. That means most of the planet's seafloor has been completely replaced many times over. If an ancient civilization had lived near the coasts or on islands, there's a very real chance their traces would now be at the bottom of a tectonic plate, turning slowly into magma deep below our feet. Continental surfaces last longer, but even they don't keep a perfect record of what happened on them. Erosion wears them down relentlessly. Glaciers scrape them clean like enormous bulldozers. Volcanic eruptions coat them in ash and lava. Forests come and go in cycles. Deserts migrate across continents. Rivers change course dramatically. Even massive impact craters from asteroids can fade over time, worn down by the same forces that reshape everything else. What looks permanent from our human perspective is often just the current state of something in constant slow motion. The Grand Canyon is often held up as a great geological archive, a natural library, layers of sedimentary rock stacked like the pages of an enormous book. But that book is missing chapters. There are significant gaps where layers were never deposited or were removed later by erosion. These gaps are called unconformities, and they're a stark reminder that the geological record isn't complete or comprehensive. It's a patchwork stitched together from what happened to survive. And survival is genuinely rare. The fossil record, which we use to understand ancient life, is incredibly incomplete. Most organisms don't fossilize, and even those that do are only found when erosion or human excavation exposes them. It's not that fossils are common and we just haven't looked everywhere yet. It's that fossils are incredibly rare and precious, and most evidence of past life is gone for good. If that's true for bones, literal pieces of living organisms, it's even more true for cultural artifacts, tools, buildings, inscriptions, technology. Even with humans whose artifacts are only tens of thousands of years old, we often find just fragments, a flint knife, a piece of pottery, a post hole in ancient soil. Archaeologists routinely reconstruct entire societies from scraps because that's usually all that remains of complex cultures. So when we ask whether another civilization could have existed millions of years ago, the burden of proof is enormous. It's not just that we haven't found their ruins, it's that the odds of anything surviving that long are already vanishingly small. And even if something did survive, it would have to be in a place that hasn't been subducted, eroded, buried too deeply, or completely transformed by geological processes. Consider how we look for impact craters from asteroid strikes. Consider how we look for impact craters from asteroid strikes. Large asteroid impacts leave distinctive scars, craters hundreds of kilometers across. But some of these craters are extremely hard to see because over time they're eroded, buried under sediment, or deformed by tectonic activity. Some we only detect through subtle gravity anomalies or slight changes in rock composition that require sophisticated instruments to measure. Now imagine trying to find something smaller than a massive crater, a city, a factory, a carved monument. Unless it was preserved in a perfect geological niche, protected from all the forces that usually destroy things, it would be extremely difficult to detect. And preservation alone isn't enough. Someone has to be looking in the right place at the right time, with the right tools and the right questions in mind. Most paleontological digs aren't specifically looking for signs of intelligence. They're looking for species, bones, ecosystems, evidence of evolution and extinction events. They examine sediment layers for traces of life and environmental changes, not for signs of roads or buildings. And if an object doesn't look obviously artificial, if it isn't clearly shaped like a tool or obviously manufactured, it might not be recognized for what it is. Even when we do find something unusual, the first assumption isn't civilization, it's natural process. And that's actually a reasonable bias. Nature is remarkably capable of producing very complex, structured patterns, crystals, geodes, erosion features, mineral veins. Without clear context, it's genuinely hard to tell what's natural and what's artificial. A perfect sphere might be a decorative object, or it might be a natural concretion formed by mineral precipitation. Without surrounding evidence, it's just a curiosity. This is part of why the Saluran hypothesis focuses on indirect evidence. Rather than looking for buildings or tools, it asks whether an earlier civilization might have altered the Earth's chemistry or climate in a detectable way. In other words, not what they built, but what impact they had on the planet's systems. Even that's hard to trace, because natural events can produce similar changes. A massive volcanic eruption, a methane release, a mass extinction event. All of these leave chemical fingerprints that can look remarkably similar to industrial activity. So the challenge isn't just finding evidence, it's interpreting it correctly. And that requires genuine humility, not because the idea of a lost civilization is likely, but because ruling it out completely requires more certainty than our planet tends to allow. We think of history as a straight line with a clear beginning and clear end, but the geological record doesn't care about lines. It cares about pressure, heat, erosion, and deposition. It rewrites itself constantly and without sentiment. And that means most of what happened on Earth, most of what was ever built, spoken, thought, or dreamed, is gone, not hidden, just undone by the patient work of time itself. We're not done, though. If the Earth is remarkably good at erasing evidence, then we need to understand what resists that cosmic eraser, what can last, not just for centuries, but for millions of years. So next we'll look at the kinds of evidence that might endure geological time and how we could possibly recognize them. Not fossils, not buildings, but something subtler, something more chemical than architectural, more stubborn than stone. When people hear the word fossil, they often picture a perfectly preserved dinosaur skeleton laid out in a museum, bones arranged just so, like the creature simply lay down and became stone over time. But real fossils rarely look like that at all. They're fragmented, partial, compressed, distorted. They take extraordinary luck, very specific environmental conditions, and enormous amounts of time. Even under the absolute best circumstances, fossilization is a rare exception, not the rule, and the story it tells is often incomplete, selective, and frustratingly quiet on many important details. The fossil record is one of the best tools we have for understanding ancient life, but it doesn't give us anything close to a full picture. It's like trying to reconstruct an entire movie from just a few still frames, some torn pieces of film, and a handful of scattered subtitles. For every species we've identified in the fossil record, there are likely dozens or hundreds that have left no trace whatsoever. Some never fossilized at all. Some did, but the remains were later destroyed by geological processes. Others still lie buried in places we haven't explored yet, waiting in the darkness. So, when we talk about the possibility of ancient civilizations, especially hypothetical ones from the deep past, it's crucial to keep in mind that we're already working with a record that's full of blind spots and gaps. Fossilization depends on a complex combination of factors that must all align perfectly. How and where an organism dies, what kind of sediment it's buried in, how fast that sediment accumulates, whether scavengers get to the body first, whether the burial site is geologically stable over millions of years, and whether erosion or tectonic activity later exposes the fossil without destroying it completely. That's an enormous number of conditions that must be met. The odds are stacked heavily against preservation from the very start. And for most of Earth's long history, The places where life thrived most abundantly, coasts, floodplains, forests, weren't particularly great for fossilization. They were too geologically active, too wet, too exposed to the elements. Now imagine trying to preserve not just bones and shells, but artifacts, tools, structures, infrastructure, things that don't even begin with the natural durability of bone or shell. The odds drop even further toward impossibility. Even stone tools, which are relatively resilient compared to organic materials, can be extremely hard to date and identify if they're found out of context. A chipped rock might be a deliberately crafted tool, or it might be just a chipped rock broken by natural processes. Without clear patterns of use or associated artifacts, it's genuinely difficult to say. And most technological materials don't survive the way bone sometimes does. Metal corrodes and oxidizes, fabric decomposes completely, plastic breaks down unless it's buried in a completely oxygen-free environment. This means that even for our own human ancestors, the record is frustratingly incomplete. Take Homo erectus, a species that existed for nearly 2 million years, an enormously successful run. We have some tools, some bones, and some evidence of fire use, but much of what they actually did is completely unknown to us. They traveled widely across continents, adapted to different climates, and likely had sophisticated forms of communication, but we don't know what they believed, how they organized their societies, or what they dreamed about. Not because they didn't leave signs, but because those signs simply didn't survive the long journey through time. When we dig into the fossil record, we're really digging into the survivors, the extraordinarily lucky ones, the rare individuals whose remains happen to fall in exactly the right spot, under exactly the right sediment, protected from too much pressure or heat, and then got lucky again when erosion or human excavation exposed them millions of years later. That's why periods of mass extinction often leave such distinct, dramatic layers in the rock record. There's often a sudden die-off, a lot of material getting buried quickly, and less time for normal decay processes to erase the evidence completely. The layers where we find the most fossils are often moments of crisis and catastrophe, not moments of peaceful civilization. So, if we were looking for evidence of a past intelligent species, we might only find them if they lived near one of these rare fossil-friendly zones, and then were caught in a preservation-friendly disaster. It's an incredibly narrow window of opportunity, and that's assuming they left bodies behind at all. Intelligent life, especially if it developed advanced technology, might have disposed of its dead in ways that don't promote fossilization, cremation, sky burials, sea burials, deliberate decomposition in designated places. And beyond that, there's a more subtle issue to consider. What if a civilization advanced to the point where it stopped leaving biological remains entirely? What if it transferred its consciousness into artificial systems or evolved into something less physical, more distributed, less organic? We don't know if that's possible, of course, but if it were, the fossil record wouldn't just be silent, it would be completely irrelevant to detecting their existence. Even now, most of the matter involved in our day-to-day lives is synthetic, non-organic, or so heavily processed that it wouldn't register as natural to someone studying our remains millions of years from now. Millions of years from now, a future geologist might find thin layers of strange polymers, rare earth elements, and metal alloys, and not immediately recognize them as remnants of a technological civilization, especially if the broader context is missing. Imagine finding a thin layer of titanium dust in a 100-million-year-old sediment core. It might raise interesting questions, or it might simply be dismissed as an unexplained anomaly. Interpretation is often just as important as observation, and that brings up something often overlooked in discussions of the fossil record: bias. Not just in what gets preserved, but in how we analyze and interpret what we find. We tend to see what we expect to see, and the idea that a sophisticated civilization might have come and gone millions of years ago doesn't fit comfortably into most current scientific frameworks. So unless the evidence is absolutely overwhelming and undeniable, it's likely to be classified as natural variation or an unexplained but probably natural anomaly, not because of negligence or conspiracy, but because that's simply how good science works. It prefers the simplest explanation that fits the available evidence. And civilizations, especially ancient vanished ones, are decidedly not simple explanations. This is exactly why the fossil record doesn't tell us everything about the history of life on Earth. It tells us what the planet allowed to be preserved. It tells us what we happen to find and excavate. It tells us what we're able and willing to interpret based on our current knowledge. But it certainly doesn't tell us the complete story of life on Earth. And it most definitely doesn't tell us everything about the possible history of intelligence on our planet. Still, we have other investigative tools at our disposal, not just bones and artifacts, but signals, signs in the soil, in the atmosphere, in the chemistry of rocks, traces left not by bodies or buildings, but by processes and activities. And that's where we'll go next, into the kinds of evidence that don't rely on fossilization, that aren't about bones at all, but about what happens when something intelligent starts to systematically change the planet it lives on. When intelligence leaves a fingerprint, not through tools or cities, but through chemistry itself. Are you finding this exploration as fascinating as I am? The deeper we go into these questions, the more I realize how much we simply don't know about our planet's deep history. If you're enjoying this journey through geological time and the mysteries it holds, please consider sharing this with someone else who might find it thought-provoking. Sometimes the best conversations start with the biggest questions. In 2018, a pair of scientists named Gavin Schmidt and Adam Frank posed a question that managed to be both wildly speculative and scientifically grounded at the same time. They asked if an industrial civilization had existed millions of years before humans evolved, would we be able to detect it in the geological record today? They weren't arguing that such a civilization actually did exist, of course. Instead, they were exploring how science would even begin to look for one, and what methods we might use to detect such ancient traces. And in doing so, they gave this intriguing question a proper scientific name, the Saluran hypothesis. The name is a playful nod to a British science fiction show where intelligent reptiles, the Silurians, had once ruled the Earth long before humans appeared. But the hypothesis itself isn't about science fiction at all. It's about testing the practical limits of geology and paleoclimatology. It's about asking whether our own dramatic impact on the planet is unique, or if it could resemble something much older, hidden deep within the Earth's accumulated layers. The premise is elegantly simple. If an industrial civilization similar to ours had developed, say, 50 or 100 million years ago, and then vanished completely, what traces would it realistically leave behind? And would those traces survive the erosion, burial, and tectonic upheaval that follows over that kind of immense time span? The scientists began with what we already know with certainty, that our own civilization is actively leaving geological fingerprints right now. We're systematically changing the composition of the atmosphere. We're altering the chemistry of the oceans in measurable ways. We're depositing synthetic materials like plastics, pesticides, and industrial byproducts into soils and sediments around the globe. These are long-lived global changes that are being recorded in the Earth's layers at this very moment. So the crucial question becomes, what kinds of changes are the most durable over geological time? And would they look any different if they were created by an earlier civilization rather than by us? The paper breaks it down into several major categories of potential evidence. One category is geochemical anomalies, sudden changes in the ratios of stable isotopes such as carbon, oxygen, and nitrogen that show up in rock layers. For instance, burning fossil fuels changes the balance of carbon isotopes in the atmosphere in a very distinctive way. This shift gets preserved in sediment layers and ice cores for thousands or potentially millions of years. If something similar happened in the distant past, it might suggest an industrial process, even if the civilization itself is long gone and forgotten. Another category is synthetic materials. Our modern world produces plastics and chemicals that simply don't occur naturally anywhere on Earth. Many of these compounds degrade slowly and could in theory survive for millions of years in some recognizable form. Tiny particles of plastic called microplastics are already turning up in sediments, oceans, and even in the air we breathe. If we find ancient layers with similar non-natural polymers, we'd have to seriously consider where they came from. There's also the question of fossil fuel use. Industrial civilizations require enormous amounts of energy. If a previous civilization burned carbon-based fuels on a large scale, that would release not just CO2, but also leave behind coal ash, fly ash, and other distinct byproducts. These could potentially accumulate in detectable layers, just like we can detect layers of volcanic ash from ancient eruptions scattered across continents. Then there are mass extinctions. Human activity has already dramatically accelerated extinction rates across many species groups. This kind of biological signature, a sharp, sudden drop in biodiversity, especially of large animals, can leave a clearly visible mark in the fossil record. If something similar happened in the past without an obvious natural cause, like an asteroid impact or massive volcanic eruption, it might hint at an intelligent agent. But here's where things get genuinely tricky and complicated. Many of these same markers could also be caused by entirely natural processes. For example, the Paleocene-Eocene thermal maximum, about 56 million years ago, saw a rapid rise in global temperatures, ocean acidification, and a major disruption in the carbon cycle. It left behind some of the same geochemical fingerprints we're producing right now. Yet as far as we know, no civilization was involved whatsoever. So how do you tell the difference between a natural event and one caused by intelligence? That's honestly the hardest part of this entire question. The Saluran hypothesis doesn't claim that we've found proof of a past civilization. It asks whether we'd even recognize that proof if it existed somewhere in the rock record. And more importantly, it asks us to think carefully about what traces we ourselves are leaving and how long they'll realistically last. Because even our most enduring markers, plastics, nuclear isotopes, industrial byproducts, aren't guaranteed to survive for tens of millions of years. They might degrade, be buried too deeply to detect, or get erased by subduction and resurfacing. Even if some traces survive, they might be scattered and extremely hard to interpret without broader context. This forces a fundamental shift in thinking. Instead of looking for traditional ruins, buildings, tools, roads, we need to think like planetary archaeologists. We need to look for subtle, indirect clues, chemical shifts, anomalies in sediment layers, disruptions in ecological patterns, and we need to be genuinely open to the idea that some of the weird features we already see in the geological record might have alternative explanations we haven't considered. This isn't a call for conspiracy theories or fringe speculation. It's a framework for asking better, more sophisticated questions, for treating the possibility of pre-human civilizations as a legitimate scientific hypothesis, not a myth or legend. And like any good scientific hypothesis, it can be tested, challenged, refined, or ruled out based on evidence. It also makes us confront a deeper, more philosophical point. If we, with all our technology and global reach, are still geologically fragile, if our legacy might vanish in a few million years, then how many other stories might have already come and gone, lost to time? Not because they were small or insignificant, but because Earth is patient and time is thorough in its work of erasure. The Saluran hypothesis doesn't tell us that someone came before us. It just tells us that if someone did, their traces would be extremely hard to find using conventional methods. And it gives us a valuable starting point to think about what to look for, how to interpret it, and what it would mean, not just for science, but for how we see ourselves in the vast story of this planet. And so we move forward carefully. If such traces do exist, they won't come to us as statues or scripts. They'll be found in rocks, in chemistry, in thin layers of strange compounds buried deep in the Earth's memory. And the real question becomes, have we already found any of them without realizing what they were? If tomorrow every human being vanished, no warning, no war, no apocalyptic event, just gone, what would the world look like a year from now? 100 years? A million? It's a grim but oddly useful thought experiment, one that helps us understand what kind of trace a civilization like ours really leaves behind, and more importantly, how long any of it might actually stick around in the geological record. In the first few days after our disappearance, not much would change visibly. Cities would still be lit by automatic systems, cars would remain where they were last parked, planes would sit grounded on runways. But very quickly, without human oversight and maintenance, the complex systems that support our technological world would begin to fail in cascading ways. Power plants would shut down as safety systems engaged. Water treatment facilities would lose pressure. Buildings would start to decay, not because of some catastrophic event, but simply because nothing is built to run indefinitely without constant maintenance and repair. After just a few years, nature would start aggressively reclaiming our cities and towns. Plants would grow through cracks in pavement with surprising speed. Roots would lift sidewalks and buckle foundations. Seeds blown in by the wind would take hold in abandoned gardens and rooftops. Animals would return to urban areas, not just rodents and birds, but deer, coyotes, and eventually larger predators in some regions. Without us to maintain the boundaries, the line between wild and built would begin to blur very quickly. In places like New York or Shanghai, subway systems would flood within days once the pumps failed. Steel structures would begin to rust in earnest. Glass would shatter from temperature changes and settling. Within decades, many buildings would collapse under their own weight, especially in wetter climates where moisture accelerates decay. Concrete, though seemingly durable, is actually quite vulnerable to moisture and temperature changes over time. Rebar inside corrodes, cracks form, and the structure gradually weakens until it fails. Roads would break apart more slowly, but they too would eventually degrade. Vegetation would tear through asphalt with remarkable persistence. Bridges, lacking regular paint maintenance and structural inspections, would eventually fall. Satellites in orbit would start to fail as batteries wore down and solar panels degraded. Most would deorbit and burn up within a few centuries, leaving only the most distant objects slowly decaying in space. After about 1,000 years, much of what defines our current presence would already be unrecognizable to any observer. Steel structures would have collapsed or rusted into unidentifiable heaps. Plastics exposed to sunlight would degrade into fragments. Underground cables and pipes would corrode away. The outlines of roads and cities might still be visible from the air, especially in drier regions, but they'd resemble faint scars more than signs of active civilization. 10,000 years on, even those scars would begin to fade significantly. Forests would fully reclaim temperate zones. Deserts would shift and migrate, burying cities under sand. Coastlines might change due to erosion or climate effects already set in motion. Whatever remained would depend heavily on location and material. Stone carvings might survive longer, think Mount Rushmore or the pyramids, but most modern infrastructure wouldn't last. Go further out to 100,000 years, and almost every surface structure would be completely gone. Only the deepest foundations, the most stable landfills, and certain geological modifications, mines, quarries, altered sediment layers, might still be detectable to a determined investigator. But even these would be weathered, filled in, or buried under new sediment, and any meaning they once carried would be long forgotten unless somehow decipherable patterns or chemical residues remained. So then we ask, after 1,000,000 years, what would actually survive of our civilization? The answer is honestly not much. Maybe a few artifacts in extremely stable dry environments, sealed caves, deep underground storage, or polar ice. Maybe some synthetic molecules that resist degradation under specific conditions. Maybe distinctive layers in lake beds or ocean sediment that show spikes in carbon, nitrogen, plastic residues, or rare earth metals. These would be the real fossils of our civilization. Not buildings or monuments, but chemical echoes, molecular signatures of a species that briefly altered its planet's chemistry. If we disappeared tomorrow, the planet would begin erasing us almost immediately, not maliciously or deliberately, just mechanically. Erosion, biological decay, plate tectonics, all the usual processes of geology would continue without interruption. And in time, the idea that we had ever been here would become harder and harder to prove definitively. This isn't just philosophical speculation, it's central to the question of lost civilizations. Because if ours could be wiped away so thoroughly, with all our global reach and technological intensity, then how could we expect the traces of any earlier civilization to have fared better? It also gives us a useful benchmark. If something about us can last, if anything at all leaves a durable global signature, then perhaps that's what we should be looking for when we ask whether we were the first. Not monuments or artifacts, but residue, transformation, chemistry. And there's another layer to consider. Some of our most persistent markers aren't things we built, but things we changed. The carbon we've released into the air, the nitrogen we've added to the soil, the isotopes from nuclear testing, the extinction of species, and redistribution of biomass. These aren't physical structures that can rust or crumble. They're planetary modifications, and they're much harder to undo. So now imagine you're a scientist millions of years in the future, carefully drilling through a core sample of ancient sediment. You see a thin, strange layer, higher levels of carbon, a sudden drop in biodiversity, traces of synthetic compounds, maybe even isotopes that shouldn't naturally be there. You might ask, what happened here? Was it a natural event, or was there something else? That's where this thought experiment ultimately takes us. By imagining our own disappearance, we get a clearer sense of what kinds of evidence actually endure over geological time, what would rise to the level of a detectable geological signal, and what would unfortunately simply disappear into the background noise of planetary processes. Next, we'll follow that signal, what it looks like, where it goes, and how it might be mistaken for something else entirely. Because even if we leave a mark, the real challenge is recognizing it for what it actually is, millions of years after the fact. What do you think would be the most likely trace of our civilization to survive millions of years? I'd love to hear your thoughts in the comments. Sometimes the most interesting insights come from considering these questions from different angles. Geologists don't speak in years the way the rest of us do. They speak in layers, in thicknesses of sediment, in isotope ratios and core samples. Deep time doesn't count seconds or seasons. It works in intervals, events, patterns that stretch beyond the scale of memory, history, or even biology as we know it. And if we want to ask whether another civilization might have existed in the ancient past, we have to learn to think in that patient, methodical language, because deep time doesn't describe what happened last week or last century. It tells you what's written in the rock, accumulated grain by grain over millions of years. Most of what we know about Earth's past comes not from fossils of large animals, but from the chemistry and structure of sediments. That includes ocean cores, lake beds, glacial ice, and the bands of rock exposed in cliffs and quarries around the world. These layers form gradually, depending on the environment: dust settling in lakes, microscopic shells accumulating on the ocean floor, ash falling from volcanic eruptions, pollen from plants carried by wind and water. The result is a kind of vast natural archive, with each layer offering subtle clues about what the planet was like at the time it was deposited. This is the true language of deep time, and while it doesn't speak in full sentences, it has a remarkably rich vocabulary: carbon levels, oxygen isotopes, sulfur ratios, pollen grains, trace metals, magnetic orientation. It tells us about ancient climate, about atmospheric composition, about what kinds of plants were growing and which species were abundant. It can even tell us about catastrophic events, asteroid impacts, supervolcanoes, mass extinctions, and in rare cases, it hints at something more unusual. Some of the most detailed records come from places that change slowly and preserve well: deep ocean floors, undisturbed lake beds, and the deep layers of polar ice. Scientists drill long cylindrical samples called cores and examine the layers centimeter by centimeter. They look for chemical shifts, variations in particle size, fossil content, mineral presence. Sometimes a subtle shift in color is enough to signal a fundamental change in the world above. These signals aren't always obvious or dramatic. Many are remarkably subtle: a slight increase in a particular isotope, an unusually high concentration of a rare element, a ratio of carbon-13 to carbon-12 that doesn't match the expected baseline for that time period. Taken alone, any of these might be natural variation. Taken together, especially if they appear in a narrow slice of sediment, they suggest something happened, something sudden or unusual enough to alter the long, steady rhythm of the planet. The Anthropocene, for example, the proposed geological epoch marking human influence, is already leaving a distinctive fingerprint. Future geologists, if they look, will likely see a sharp spike in carbon dioxide levels, a dramatic drop in biodiversity, traces of synthetic chemicals, and fallout from nuclear testing. This thin line in the Earth's crust will stand out against the background rhythm of prior ages. It's not a complete story, but it's a clear disturbance, a marker that something unusual was happening. And that's exactly the kind of thing scientists today are trained to notice and investigate. So, if an earlier civilization had changed its environment in similar ways, even without leaving fossils or ruins, we might expect to find comparable signals somewhere in the rock record. But interpreting them correctly is another matter entirely, because for every spike in carbon or trace of a rare metal, there are potential natural explanations as well. Volcanoes can release enormous amounts of carbon, asteroid impacts can scatter iridium across continents, microbial blooms can leave odd chemical residues. The planet has its own extensive vocabulary of disaster and change, and it's surprisingly easy to misread the source of an anomaly if you automatically assume all causes must be natural. This is why context matters so much. It's not enough to find a single chemical signature. It needs to line up with other evidence: a temperature rise that coincides with mass extinction, a strange compound appearing globally rather than just locally, a sudden jump in heavy metals alongside other indicators of industrial activity. Only by carefully assembling these pieces can we begin to suspect something more than pure chance or natural catastrophe. And even then, we're making educated guesses. The deeper into time we look, the fewer tools we have for certainty. Many of the most dramatic geological events occurred hundreds of millions of years ago. Whatever clues they left behind have been stretched, folded, buried, and exposed more than once. Rock is durable, but it's also changeable over vast timescales. Signals get scrambled, layers disappear, nothing stays perfectly clean and readable. Still, some signals are remarkably stubborn. There are isotopes that decay so slowly they act as reliable time markers for millions of years. There are shifts in magnetic orientation that match known cycles in the Earth's magnetic field, giving us a kind of planetary calendar. There are minerals that form only under very specific conditions, certain temperatures, pressures, or chemical environments. These are the phrases, the punctuation marks in deep time's language. If a civilization affected the world strongly enough and in just the right way, those effects might show up here, written in the patient accumulation of sediment and stone. But the tricky part is recognizing them for what they are. Even now, scientists occasionally find unexplained anomalies, spikes or shifts that don't match any known natural events. Most are eventually attributed to natural causes we hadn't considered. Some remain unexplained, sitting quietly in the scientific literature, neither dismissed nor actively pursued, not because they're unimportant, but because without more context, there's not much else to do with them. Science needs patterns, not just isolated points, and that might be exactly where the traces of an ancient civilization would sit, hidden in plain sight, misfiled as a natural event, waiting for someone to ask the right questions. If the signature was brief or faint or localized, it might not raise immediate alarms, or it might be attributed to something familiar, like a volcanic burst, or a methane release, or a sudden climate fluctuation caused by orbital changes. All of these are well-known phenomena. All have occurred many times in Earth's history. To say something intelligent did this instead would be a bold claim, one that requires not just unusual data, but a framework to explain why intelligence is the most likely source. Without that framework, even a correct hypothesis would likely be ignored or dismissed. That's not a flaw in science. It's part of how science protects itself from wishful thinking and maintains rigorous standards. But it does mean that some possibilities, however intriguing, remain unexplored simply because they don't fit into current paradigms. So the language of deep time is real and measurable. It's there in the rock, in the chemistry, in the slow rhythm of sediment and isotope accumulation. It tells us what changed, roughly when, and often how, but not always why. That part requires interpretation, inference, and sometimes imagination. And it's in that interpretive space that the question of lost civilizations continues to exist, unproven, perhaps unprovable, but not impossible. Next, we'll explore what signs might still exist, those stubborn pieces of the puzzle that refuse to fade completely, not the grand structures or detailed stories, but the leftovers, the scraps, the accidental fossils of intelligence, if any exist at all. Because if something came before us, the odds are it didn't intend to leave a monument. It simply lived, and in doing so may have changed the planet in ways it couldn't have known would one day become questions for us to ponder. Some things vanish quickly from the geological record. Paper, cloth, wood, these disappear in decades or centuries at most. Others hang around a little longer: glass, metal, concrete. And then there are things that outlast entire civilizations, not because they were meant to, but because they just happen to resist the forces that usually take everything else apart over time. When we talk about the potential traces of an ancient, unknown civilization, we have to think in those terms, not what was deliberately built to last, but what lasts by accident or by virtue of its chemical properties. And it turns out the list of truly durable markers is surprisingly short. One of the most persistent markers a civilization can leave isn't architecture or technology, it's chemistry. When we mine metals, synthesize new compounds, burn fuels, or systematically alter the composition of the atmosphere, we're changing the planet in ways that can be written into sediments and soils for millions of years. Those changes are often microscopic, but they're widespread, and when they occur rapidly or globally, they leave sharp signatures that stand out from the background. Future scientists might not know exactly what happened, but they'll know something significant did happen during that time period. Let's start with synthetic materials. Modern humans produce a staggering variety of substances that simply don't occur naturally anywhere on Earth. Plastics, pesticides, industrial chemicals, rare metal alloys. Some of these break down quickly when exposed to sunlight or oxygen. Others are remarkably persistent, especially when buried in the right conditions. Microplastics, for instance, are already turning up in the most remote sediments on Earth. Deep ocean floors, polar snow, high-altitude soils. Some studies suggest they could remain intact for tens of thousands, maybe hundreds of thousands of years under the right conditions. But even plastic has its limits. Left near the surface, most of it degrades eventually. In oxygen-free environments, it might last much longer, but it also becomes harder to detect and identify. And plastics alone don't definitively prove intelligence. A thin layer of strange polymers might raise interesting questions, but without context, without evidence of deliberate production and use, it might just look like an odd natural deposit, especially if everything else has disappeared. Then there's metal. We tend to think of metal as highly durable, and it is under the right circumstances, but most metals corrode over time, especially when exposed to moisture and oxygen. Iron rusts completely, copper oxidizes. Even stainless steel, which resists corrosion much better, doesn't hold up forever under all conditions. Metal artifacts might last a few thousand years if left untouched in a dry environment, but millions of years? That's extremely unlikely unless they were sealed in a highly stable environment, say inside a mountain or deep underground. And even then, they'd be hard to distinguish from natural ore deposits unless they were shaped or patterned in very obvious ways. Radioactive isotopes present a different kind of signal. Some are synthetic, created only through nuclear reactions. These include isotopes like plutonium-244 or certain transuranium elements that don't occur naturally in significant quantities on Earth. If found in the geological record outside of known nuclear events, they might suggest technological activity, but most artificial isotopes have half-lives short enough that they decay to undetectable background levels over millions of years. Still, some isotopes like technetium-99 or iodine-129 persist long enough that traces could potentially remain under very specific conditions. Fossil fuel combustion leaves another possible signal. Burning coal or oil releases carbon dioxide with a distinctive isotopic signature, specifically a lower ratio of carbon-13 to carbon-12 compared to atmospheric carbon from other sources. If this kind of shift appeared suddenly and globally in ancient sediments, it might suggest large-scale combustion by some intelligent agent. But again, there are natural processes that can cause similar patterns, including massive volcanic activity and methane releases from geological sources. We'd need additional clues to support a technological source rather than a natural one. Another possibility is unusual concentrations of certain metals like lead, cadmium, or rare earth elements often used in electronics and manufacturing. Mining and refining these elements inevitably leaves waste products. If found in high concentrations in ancient soils or sediments, especially in patterns that suggest processing rather than natural distribution, they could potentially be evidence of industrial activity. But these elements move through ecosystems in complex ways over geological time. They bioaccumulate in organisms. They leach through groundwater. They migrate through soil layers. Isolating a specific source isn't easy, especially after millions of years of geological activity. What about physical structures? Deep, massive earthworks. Things like quarries, tunnels, or underground facilities might survive longer than surface buildings, especially if they significantly altered the local geology. But identifying those after tens of millions of years would be extremely difficult, especially if tectonic forces have shifted or buried the region. Erosion, collapse, and sedimentation can erase even large features over geological time. And without clear artificial geometry, it's genuinely hard to distinguish a human-made cavern from a natural cave system. Concrete is surprisingly durable, and some formulations can actually strengthen over time due to ongoing mineralization processes. Ancient Roman concrete, for example, has survived for over 2,000 years, often in harsh marine environments. Modern formulations might last even longer under ideal conditions, but again, exposure matters enormously. Moisture, temperature shifts, and biological growth all take their toll, and in deep time, even concrete can become unrecognizable, just another odd formation in the rock. Ceramics and glass are potentially better candidates for long-term survival. They're chemically stable, and shards of ancient pottery are often among the most persistent human artifacts found by archaeologists. Under the right conditions, ceramic fragments could conceivably last for millions of years, especially if they were buried quickly and not exposed to repeated cycles of freezing and thawing. But fragments alone tell us very little. They'd have to be obviously shaped, clearly patterned, or present in large, statistically unlikely concentrations to suggest artificial origin rather than natural processes. Then there are indirect signals, changes to ecosystems, food webs, or soil chemistry that persist long after the civilization itself has vanished. Modern agriculture fundamentally transforms landscapes. It compacts soil, depletes certain nutrients, alters natural erosion patterns. Irrigation changes local water chemistry. Fertilizers leave distinctive chemical residues. Deforestation and monoculture farming dramatically reduce biodiversity in predictable ways. Even after complete abandonment, these effects can persist in soil profiles for thousands, maybe tens of thousands of years. Not nearly enough for deep geological time, but more persistent than most human-made objects. All of this means that if a past civilization existed, the most durable signs would likely be remarkably subtle, not monuments or obvious artifacts, but patterns and anomalies, something unusual in the sediment that doesn't belong according to natural processes, but disruption in the slow rhythm of natural cycles, and those signs would have to be found, correctly identified, and properly interpreted. No small task when working with rocks that are already older than most species that have ever lived. Meanwhile, the signs that don't last are all around us right now. Books, photographs, art, music, the actual content of our lives and culture. They're the first to go when a civilization ends. Paper burns and rots. Hard drives degrade and become unreadable. Digital signals vanish when the power goes out permanently. Cultural knowledge, the stories, symbols, meanings, disappears even faster than physical buildings. Within just a few generations, even among survivors, languages can die out completely, belief systems can fade, and once central truths can become mysteries that no one remembers how to solve. So we come back to the fundamental question: what actually lasts? Not much, but maybe just enough. Enough to leave a trace, if not a complete story. Enough to make someone someday stop and wonder, not about who we were exactly, but whether someone once was, and whether the Earth, despite everything it's systematically erased over billions of years, might have kept a few stubborn signals hidden in its slow, silent archive. Do you ever think about what traces of your own life might outlast you? Not in a morbid way, but just wondering what physical evidence of our individual existence might persist. I find these questions both humbling and oddly comforting. Please share your thoughts. I'd love to know what aspects of this deep time thinking resonate with you. Next, we'll look at how some of these potential signs might behave in one of the most dynamic environments on Earth, the ocean. Because if a civilization ever touched the seafloor, the ocean didn't just cover it up. It may have systematically taken it apart, molecule by molecule. The ocean doesn't preserve secrets the way we might hope. It breaks them down, scatters them, buries them, scrapes them away with relentless efficiency. To a civilization living near or interacting heavily with the sea, this might not have seemed like a threat at the time. After all, water sustains life. It connects continents. It provides food, transportation, and inspiration. But when it comes to preservation over millions of years, the ocean is a relentless editor, systematically erasing nearly everything it touches. And for a civilization that left its mark below sea level, the odds of us finding that mark today are essentially zero. Still, it's worth asking, if a technological civilization had once existed and interacted with the ocean in any meaningful way, what kind of trace would it leave? And would that trace pass the ultimate test of deep time? Start with the basics. Today, most major cities are built near coastlines. It's practical, easy access to trade, abundant resources, and milder climates, but it also makes them incredibly vulnerable. Coastlines shift dramatically. Storms erode entire beaches, sea levels rise and fall, and in geological terms, the oceans move with surprising speed. Over just the last 20,000 years, sea levels have risen over 120 meters, completely flooding entire continental shelves. During past ice ages, vast areas of what is now deep underwater were dry land. Rivers ran through them, people lived on them, animals migrated across them. Now those regions are submerged beneath layers of sediment and salt water, difficult to access and almost impossible to study comprehensively. This makes the search for any ancient civilization that lived along ancient coastlines inherently problematic. Not because it's implausible that such a civilization might have lived there, quite the opposite, but because those are precisely the regions that have been systematically erased, buried, or made completely inaccessible by rising seas. Underwater archaeology is challenging under the best of circumstances. Doing it on submerged continental shelves, buried beneath layers of post-glacial sediment, is something else entirely. Let's say some past civilization developed sophisticated maritime technology. Not just simple boats, but harbors, ports, maybe even extensive coastal infrastructure. What happens to those structures over deep geological time? Wood decays completely, ropes rot away, stone structures collapse, metal corrodes extremely quickly in saltwater environments. Unless the structures were buried very quickly under silt or sand in a low-oxygen environment, there's virtually no chance they'd survive for more than a few thousand years, let alone millions. And even if they did somehow survive, they'd be nearly impossible to detect without targeted, high-resolution scanning of vast areas. Artificial structures could theoretically leave some geomorphological traces, straight lines, unnatural angles, repeating patterns in the seafloor topography. But nature can produce surprisingly geometric features as well, especially in marine environments. And most underwater anomalies, once actually investigated, turn out to be natural formations. Without clear context or associated artifacts, it's extremely difficult to argue otherwise convincingly. Now, let's think bigger. What if the civilization wasn't just near the ocean, but used it intensively? Maybe for waste disposal, mining, or energy generation. Could those activities leave a detectable signal in the geological record? Modern humans, for example, have already left a clear geochemical footprint in the ocean that will persist for a very long time. There are plastic gyres, massive floating garbage zones. There's mercury and lead contamination in deep-sea fish. There are radioactive isotopes from mid-20th century weapons testing. there are traces of industrial fertilizers causing dead zones near coastlines, and microplastics have been found at the bottom of the deepest ocean trenches, carried there by sinking currents and marine life. Some of these signals might persist for tens of thousands of years, especially those that get buried in sediment layers. If an ancient civilization had introduced synthetic compounds or altered marine chemistry on a large enough scale, those changes might theoretically be detectable today, but they'd be extremely subtle, and even if they were found, they'd have to be distinguished from natural processes. Hydrothermal vents, volcanic activity, and organic matter decomposition all leave their own complex chemical signatures in marine sediments. This is the essence of what you might call the lost tech test. Could the technological activity of a long-vanished civilization survive in a way that's still legible today? And if it did, would we recognize it as artificial, or would we classify it as an unexplained anomaly, or worse, overlook it entirely? Consider synthetic molecules. Modern plastics and industrial chemicals don't exist in nature and are extremely resistant to degradation under certain conditions. A few, under very specific circumstances, could last for hundreds of thousands of years. Buried in anaerobic sediment on the sea floor, fragments or chemical residues might theoretically survive. But again, the challenge is scale and recognition. One fragment means essentially nothing. A widespread pattern means much more, and patterns are far harder to find than individual artifacts. They require data from across regions, depths, and time frames, something that's only just beginning to happen in marine science today. Then there are heavy metals and rare earth elements used in electronics and industrial processes. These elements are systematically mined, concentrated, and often discarded in ways that create distinctive signatures. In theory, unusually high concentrations in sediment layers could point to processing or pollution, but many of these elements also occur naturally in volcanic and hydrothermal systems. And distinguishing artificial from natural enrichment isn't always clear-cut. You'd need very specific ratios, clear context, and a precise understanding of what the natural background levels were at that time. Even underwater mining leaves ambiguous traces. Modern deep-sea mining has already been proposed for extracting manganese nodules and other valuable resources from the ocean floor. If something similar happened in the distant past, the only clues might be altered sediment composition, disturbed layering, or the absence of expected minerals. But how do you detect an absence reliably? And how do you prove it was caused by technology rather than natural geological processes? Energy use is another angle to consider. Any civilization reaching a certain level of complexity is likely to consume significant energy, and that consumption inevitably leaves waste products, heat, emissions, and byproducts. In the ocean specifically, this might include increased water temperatures near industrial zones, altered current patterns, and chemical runoff. If a past civilization used energy sources that produced durable byproducts, radioactive materials, synthetic chemicals, some of those might be detectable in ancient sediments, but again, only if they were widespread or concentrated enough to stand out against the natural background variation. The problem isn't that these traces can't exist in principle. The problem is that even if they do exist, they don't immediately scream civilization to investigators. They look like chemistry, like anomalies, like odd blips in a dataset full of natural variation. And unless they're accompanied by something more obvious, clear geometry, repetition, tools, or unambiguous signs of construction, they remain unexplained curiosities, just more noise in the long, slow signal of planetary processes. So the lost tech test is a genuine challenge. It's not about whether advanced technology existed in the past. It's about whether the right combination of materials, processes, and environmental conditions could allow even a sliver of that technology to be found after tens or hundreds of millions of years. and whether anyone would know what they were looking at if they did find it. Next, we'll turn back to the surface again, not to look for what's gone, but to listen for what remains. Because while the ocean systematically wipes things clean, some places hold on to stories for much longer, and sometimes those stories show up in the most unexpected forms, not in metal or stone, but in memory, in tales passed down through generations, and in echoes too strange and persistent to ignore completely. When people talk about cities lost to the sea, the first names that come up are usually Atlantis or Lemuria, myths passed down through generations, half-remembered, often repurposed by fiction and fantasy. But the real ocean has been systematically swallowing real cities for a very long time, and not one of them left behind anything close to a monument under the waves. The sea doesn't preserve, it systematically dismantles. It works slowly but relentlessly, and it doesn't stop. And when a city falls into it, what remains after a few thousand years, let alone a few million, isn't stone columns or mosaic floors. It's silence. Coastal regions have always drawn civilizations, and for good reason. Fertile land, easy access to trade, predictable weather patterns. These are the conditions under which complexity tends to form and flourish. And yet, by building on the coast, you're also building on a fault line between stability and motion. Coastlines aren't fixed features. They migrate with tides, storms, earthquakes, and the long, slow breathing of glacial cycles. Sea levels rise and fall dramatically. Land lifts and sinks. What is now dry land might have been seabed 50,000 years ago, and what is seabed today might have been a thriving settlement before the ocean came for it. Take Dwarka, a site off the coast of India, often cited as one of the oldest underwater urban ruins ever found. Some structures there appear to be human-made, but the exact nature of the site remains hotly debated. Erosion, biological growth, and sedimentation have significantly altered whatever materials might have been there originally. Other examples include Pavlopetri off the coast of Greece, or parts of the Doggerland region in the North Sea, once inhabited, now completely submerged. In each case, traces are faint, fragmentary, extremely difficult to interpret with confidence. They're found not because they're well preserved, but because they're relatively close, shallow, and recent in geological terms. Go further back in time, and the ocean doesn't just bury, it systematically erases. The seafloor is constantly being reshaped by powerful forces. Currents redistribute sediment, marine organisms colonize and transform surfaces, corrosion eats away at exposed metal and concrete, and most importantly, new layers are always being added on top. Anything that isn't buried quickly and deeply enough gets broken down by chemical, mechanical, or biological processes. This is why submerged cities don't look like cities for very long. Even stone structures can't withstand the combined effects of salt water, wave energy, and bioerosion indefinitely. Over centuries, corners round off, carvings fade away, mortar dissolves, organic material disappears entirely, and eventually, what's left blends in with the surrounding geology. A tumbled wall might become an underwater ridge. A collapsed building might be mistaken for a natural rockfall, and that's for cities that have only been underwater for a few thousand years. Imagine one that's been gone for 10 million years. Even if it had once stood with towers and streets, with architecture far beyond our own, the ocean would not have kept it in any recognizable state. It would have systematically chewed it down, turned it over, and scattered the pieces until they were indistinguishable from natural seafloor rubble. There's also the issue of accessibility. Most of the ocean floor is still essentially unexplored. We've mapped the moon in more detail than we've mapped the deep sea, and even when we do survey underwater areas, resolution is often frustratingly low. It's enough to find seamounts and trenches, but not enough to pick out small features, especially if those features are buried or significantly degraded. Sonar, submersibles, and core sampling help, but they're slow, expensive, and limited in scope. If something's there, It has to be obvious, or we have to already know where to look. Otherwise, it stays hidden in the vast, dark expanse of the ocean floor. Some researchers have tried to approach this problem by studying sediment cores from ocean basins. These cores act like time capsules, preserving the chemical makeup of seawater, dust, and organic matter going back tens of millions of years. They can tell us about temperature, salinity, productivity, and major disturbances, volcanic eruptions, asteroid impacts, and even abrupt climate events. And sometimes they contain genuinely strange signatures. A sudden spike in carbon, a layer rich in metals or rare isotopes, chemical compositions that don't fit expected patterns. But none of these so far have been conclusively linked to intelligent activity, at least not yet. That doesn't mean the signals aren't there somewhere. It means we may not yet have the tools, the data, or the frame of mind to interpret them that way. If an ancient civilization built extensive coastal infrastructure, if it produced waste that entered the oceans on a large scale, if it altered marine ecosystems globally, some trace of that might exist in the chemical record. But those changes would have to be significant, global, and rapid to be distinguishable from natural processes. And even then, the story would be extremely hard to piece together. Think of the Fukushima nuclear accident in 2011. Within days, radioactive isotopes entered the Pacific Ocean. Within months, they were measurable off the coast of North America. That's a modern, well-documented event with known causes and precise measurements. Now imagine trying to detect something similar 50 million years after the fact, with no written records, no context, and most of the original radioactive material long decayed or diluted beyond detection. Even if some isotopes persisted in some form, distinguishing their origin would be extremely difficult guesswork at best. The ocean is not just a storage space, it's an active processor. It cycles water, nutrients, and sediment through complex physical and biological systems. It systematically chews up evidence and incorporates it into the broader churn of planetary processes. Cities don't sink and sit there untouched like some fantasy version of Atlantis. They dissolve, they blend, they become part of the sea's deep memory. And unless you catch them in the act of vanishing, they become part of the sea's deep memory. A memory written not in maps or ruins, but in gradients of chemistry and shape. So if a city falls into the sea and no one remembers it, was it ever really there from a geological standpoint? Probably not, or at least not in a way that's easy to prove definitively. But these sunken landscapes still matter enormously, not because they hold proof of forgotten civilizations, but because they remind us of how quickly complexity can vanish, of how fragile our presence is, even when carved in stone. They're not relics of ancient alien visitors from 100 million years ago. They're warnings, previews, gentle reminders that permanence is something humans invented, and that nature doesn't recognize the concept. We'll move next from the sea to the stone, from things buried by water to things sealed in rock, because while the ocean systematically devours evidence, geology sometimes preserves it. And once in a while, the planet itself seems to hold on to something it shouldn't. Not a building or a script, but a mystery, a thing that doesn't belong. And the closer we look, the more it seems to whisper that history might not be finished, telling us what it knows. How do you feel about the ocean as this vast eraser of history? Does it make you think differently about coastal cities today, knowing how temporary they might be in geological terms? I'd love to hear your thoughts on how this perspective changes the way you think about human permanence. When scientists study rock layers, they're usually looking for clear patterns, recognizable sequences that help explain what the Earth was doing at a particular time in its long history. Was the climate hot or cold? Were there active volcanoes? Were there oceans covering the area? What kind of life existed? Each layer is like a data point, a page in a vast planetary logbook, written in minerals and accumulated dust. But now and then, they find something that doesn't quite fit the expected pattern, something out of place or out of time. These are called anomalies, and while most eventually get reasonable explanations, some still sit in the margins of scientific literature, waiting for new tools or new ideas to make sense of them. Not all anomalies are particularly mysterious, of course. Geology is naturally full of unusual but explainable formations, mineral inclusions, fossil oddities, complex layering caused by environmental shifts. But every so often, something turns up that resists easy classification, a fragment that looks suspiciously manufactured, a composition that doesn't match the surrounding matrix, an object embedded in stone that seems too regular, too shaped, too deliberate to be natural. Take the case of the famous artifact in coal stories, mostly from the 19th and early 20th centuries. Miners occasionally reported finding metal objects inside lumps of coal. Sometimes it was a chain, other times a bell, or a piece of carved stone. These claims were often poorly documented, with few surviving samples and no clear provenance. Skeptics rightly pointed out that mining is messy work. Coal seams can break, collapse, and mix with modern debris, and confirmation bias was probably a significant factor. People saw what they expected or wanted to see, but the stories remain in circulation, not because they prove anything, but because they highlight the kinds of signals people think to look for when they wonder about ancient technology. Then there are the metallic spheres found in South African mines, often cited by fringe theorists as evidence of ancient technology. These small grooved objects were embedded in Precambrian rock more than 2 billion years old, but careful studies showed they were most likely natural concretions formed by mineral accumulation under high pressure. The grooves may have come from natural deformation processes. Interesting? Yes. Manufactured? No. Anomalies like these often sit on the edge of scientific attention. Some are never investigated thoroughly because they lack clear context. Others are dismissed because the burden of proof for an extraordinary claim is rightly very high, and most can eventually be explained with a little more time, better sampling, or new data, but a few remain genuinely unexplained, not proven artificial, just unresolved. And that's a key point. The scientific process is appropriately cautious. It doesn't leap to dramatic conclusions. It favors known mechanisms over unknown ones, and it demands repeatable evidence, not one-off curiosities. So even if something genuinely strange is found in ancient rock, the first questions are always the same. Could this have happened naturally? Is there contamination? Was the layer disturbed by later geological activity? Has the sample been verified by multiple independent methods? Unless the answers to all those questions are clear, the anomaly stays in limbo. Still, not all anomalies are physical objects. Some are chemical. Take, for instance, the isotope excursions, abrupt planet-wide shifts in the ratios of certain elements, like carbon or oxygen. These are visible in rock layers as sharp changes in geochemistry. Most have known causes: massive volcanic eruptions, methane releases, or asteroid impacts, but the mechanisms aren't always fully understood. Some events show signs of rapid warming, ocean acidification, and extinction, all packed into a thin slice of geological time. Some scientists have compared these to what we're doing now with industrial emissions, and a few have asked quietly whether such patterns, if found in the distant past, could ever point to intelligent activity. The answer is usually no, not because it's impossible, but because there's no compelling reason to jump to that conclusion. Intelligence isn't needed to explain most geological events, but what if one of these anomalies couldn't be explained by any natural process we know of? What if a particular layer had chemical signatures that matched industrial processes precisely: synthetic molecules, stable isotope ratios, rare metals distributed globally, with no volcanic or astronomical source? That would be much harder to dismiss. but we haven't found such a layer, or if we have, it's sitting in a database somewhere, labeled unusual, waiting for a question that hasn't been asked yet. It's also worth remembering that many important discoveries come not from looking for something specific, but from noticing something odd and refusing to ignore it. Plate tectonics, for example, was once considered fringe science. So was the idea that an asteroid wiped out the dinosaurs. The data was there for decades, but it didn't make sense until someone connected the dots in a new way. Anomalies are only meaningful when someone takes the time to see what else they might be saying. And that's where this ties back to lost civilizations. If any traces exist, they might not be dramatic. They might not be obviously artificial carvings or artifacts. They might be subtle, an unusual mineral deposit, a strange distribution of metals, a synthetic molecule embedded in an ancient layer. Things that on their own don't obviously say technology, but together might raise the possibility. It's also quite possible we've already found some of these things, but interpreted them through the lens of what we expect to find. A pattern in geology that looks like a result of natural weathering, a layered structure dismissed as a sedimentary oddity, a geochemical spike explained by a microbial bloom or a methane burst. And most of the time, that interpretation is probably correct. But what if, in rare cases, it isn't? We don't know how a truly ancient civilization would manifest in the rock record. We don't know how long its traces would last, but we do know what does last over geological time. And it's in those lasting things, the anomalies, the residues, the unexplained patterns, that any signal, however faint, would have to survive. And so we keep looking, not with the expectation of finding a buried city, but with the quiet possibility that somewhere, layered deep beneath our assumptions, there's a message, not written in words, but encoded in data, not left intentionally, but left all the same. Next, we'll take a brief step away from geology and into a different kind of record, not carved into stone, but carried through stories, because sometimes history doesn't disappear completely. Sometimes it echoes, and the line between memory and myth can be thinner than we like to admit. What's your take on these geological anomalies? Do you think we might be missing clues because we're not asking the right questions? Or do you think the explanations we have are probably correct? I'm always curious about how people weigh evidence when dealing with these edge cases in science. When archaeology runs out of artifacts and geology runs out of clear layers, what's left are stories, not scientific records, not precise measurements, but myths, oral traditions passed down through generations, sometimes across entire civilizations. Most are significantly changed in the telling. Details shift, meanings blur, symbols layer over each other like sediment, but myths persist with remarkable tenacity. They survive even when buildings fall and languages die completely. And while they're rarely taken as literal history by modern scholars, there's a growing understanding that some of them may hold fragments of real events, coded, distorted, but not entirely imagined. This idea isn't particularly new. Cultures around the world have myths about floods, fires, stars falling from the sky, or lands that once were but are no more. They describe golden ages that ended suddenly, lost knowledge, sudden darkness, strange visitors, islands swallowed by the sea. Taken separately, each story sounds like symbolic fiction. Taken together, they begin to form intriguing patterns, shared anxieties, shared experiences, perhaps even shared memories of events that happened long before written language existed. One of the most persistent themes is the flood. It appears in Sumerian, Babylonian, Greek, Hindu, Norse, and biblical traditions, among many others. The details vary considerably, but the core is remarkably consistent. A vast deluge wipes out a previous world, often as punishment or renewal. Sometimes a few survivors are warned, Sometimes they build boats, sometimes they climb mountains. It's tempting to see this as simple metaphor, an explanation for seasonal rains, or a reflection of human vulnerability to natural disasters. But there's also solid geological evidence of dramatic sea level rise and coastal flooding, especially at the end of the last ice age. Glaciers melted, seas rose by over 120 meters, and entire landscapes were drowned. People living near those coasts would have seen their world literally vanish beneath the waves, and their descendants may have told stories about it for thousands of years. Other myths speak of lost lands: Atlantis, Mu, Kumari Kandam, High Brazil. These places are often described as advanced, beautiful, and ultimately doomed. The reasons for their destruction vary: hubris, war, cosmic punishment. But the endings are always the same. The land sinks, the people vanish, and only the tale remains. Most of these stories are viewed today as pure fiction, inspired by philosophical allegory or nationalist folklore, but even fiction can preserve echoes of real events. The memory of a submerged land might be genuine, even if the details are not. There are also stories of knowledge lost. Many traditions speak of a time when people knew more than they do now, when ancient wisdom was common, when the stars were understood, when the earth was shaped deliberately. These ideas aren't proof of anything, but they do raise an interesting question. How do cultures come to believe they used to know more than they do now? Not every tradition holds this view, but the ones that do often describe a fall, not just a moral one, but a loss of information, of skill, of contact with something greater. And then there are the anomalies in ancient texts: tales of machines, flying vehicles, cities in the clouds, weapons with unnatural power. In most cases, these are clearly metaphorical or symbolic, but occasionally the descriptions get oddly specific, too specific, some argue, to be pure invention. Defenders of the myth as memory idea suggest these might be distorted recollections of something real, technologies or events passed down through oral tradition long after the original context was lost. It's a difficult position to test scientifically. Myths aren't evidence in the usual sense. They're not dated. They don't come with calibration marks or geological context, but they are part of the human record. And when multiple cultures tell similar stories without clear contact, it's worth asking why. Modern scholars in anthropology and archaeology have begun to revisit this question, not in search of ancient astronauts or secret continents, but to better understand how oral history actually works, how stories are preserved, adapted, and passed down across generations. In some indigenous traditions, oral accounts have proven remarkably accurate when matched with archaeological or environmental evidence. Entire landscapes have been described in stories: river paths, glacial retreats, volcanic eruptions, centuries before written records existed. This means that myths aren't just fantasy, they're compressed history, shaped by culture and language, but rooted in experience. They may contain metaphors, yes, but metaphors for something real, and sometimes with enough patience and cross-referencing, those metaphors can be decoded. None of this proves that an earlier civilization existed, but it does complicate the idea that history begins with writing. The absence of a written script doesn't mean the absence of memory, and in a world where physical evidence is fragile, but stories can last for thousands of years, maybe myths deserve a second look. They might not tell us exactly what happened, but they might tell us that something happened and that it mattered enough for people to try and preserve it in the only form they could, wrapped in symbol and story, passed from voice to voice across the generations. We'll continue by turning our attention to the ground, literally to the bits and pieces we've pulled from the earth that seem at times out of place. Not myths, not metaphors, but actual materials, things with shape, weight, and texture. some ordinary, some strange, and some that raise just enough questions to keep this old idea alive. Tektites are small, glassy objects scattered across parts of the Earth, often dark in color, aerodynamic in shape, and surprisingly consistent in composition. Most geologists agree they're the product of impact events formed when a meteorite strikes the planet, melts local rock, and sends droplets of molten material into the atmosphere where they cool and fall back to the ground. They're fascinating, but not particularly mysterious, at least not in isolation. What becomes more interesting is how often these odd bits of material, tektites, metal fragments, shaped stones, get lumped into stories that stretch beyond conventional geology. Stories of lost technologies, vanished builders, tools where there shouldn't be tools. And while most of these claims don't survive rigorous scientific scrutiny, some of the artifacts they center on are genuinely real, not alien, not magical, just hard to classify definitively. They sit in museum drawers, misfiled or understudied, not because of conspiracy or negligence, but because science naturally moves on when something doesn't fit cleanly into existing categories. Take the so-called out-of-place artifacts, usually shortened to OOP arts. These are objects that appear to have been found in geological strata that predate known human history. Examples include metal spheres in billion-year-old rock, carved objects in coal, or machined-looking items embedded in stone. Almost all of them have been explained as misidentifications, hoaxes, or natural formations. But the persistence of these stories tells us something, not necessarily about ancient machines, but about how hungry people are for a different narrative. One where civilization didn't start just 10,000 years ago, but has been coming and going for much longer. Sometimes these artifacts are genuinely curious. A polished stone ball with perfect symmetry, a copper tool discovered in a layer thought too old for metallurgy, or a carved pattern found deep in a cave where no known culture was thought to have reached. In nearly every case, there are reasonable natural explanations, or at least plausible ones. Geology can produce surprisingly regular shapes. Chemical weathering can etch rock in strange ways, and tools can move through layers due to animal activity, groundwater shifts, or human error during excavation. But even if none of these objects turn out to be the smoking gun for a lost civilization, they raise an important point. The deeper you go into the past, the harder it becomes to prove or disprove anything with certainty. Sediment gets churned, caves collapse, dating methods rely on context, and context can be lost or contaminated. If a technological object were buried in a layer 10 million years old, and it didn't match anything we knew about that time period, we wouldn't automatically conclude it was ancient technology. We'd probably assume contamination, a misplaced sample, a modern object that somehow found its way down through cracks or animal burrows, and most of the time, that assumption would be correct. But that assumption, though statistically sound, makes us almost blind to the rare cases where it might be wrong. Tools, real tools, can survive for a surprisingly long time under the right conditions. Stone tools in particular are quite resilient. We've found chipped flints over 2 million years old, showing deliberate shaping, clear use, wear, and evidence of cultural transmission. What's notable is that it took a long time for archaeology to recognize some of these artifacts as tools at all. For years, many were dismissed as geofacts, naturally broken stones. Only when patterns emerged, repetition, clustering, wear marks, did the scientific community begin to accept their human origin. This has a direct lesson for the search for any non-human civilization. The first signs wouldn't be cities or machines. They'd be patterns, tools that don't match local geology, arrangements of materials that suggest planning, regular shapes appearing more often than chance would allow. but those signs would be extremely easy to overlook, especially without context. And context is fragile over geological time. Imagine finding a perfectly shaped sphere in a layer of rock dated to 100 million years ago. The immediate assumption would be that the layer has been disturbed, that the object is intrusive, and that might very well be true. But if we automatically dismiss every anomaly that doesn't fit the known timeline, we close the door to discovering anything that might change that timeline. Then there are the tall tales, stories passed down or published in fringe journals about impossible finds: an iron nail in sandstone, a mechanical device in coal, a human footprint next to a trilobite. These claims almost always fall apart under investigation: poor documentation, no surviving sample, or obvious tampering. But not all are deliberate hoaxes. Some come from well-meaning observers who didn't have the tools or background to interpret what they found correctly. And some are just honest mistakes, natural features that looked artificial in the moment. Yet the idea behind these stories, that something came before us, isn't inherently wrong. What's usually flawed is the evidence presented, but the motivation is understandable. People want to know that history is deeper than we think, that our story might be part of a longer, more complex arc. And in a way, that's not just hopeful, it's logical, because intelligence isn't a one-time event, it's an emergent property. And over billions of years, it's reasonable to ask whether it's happened more than once on this planet. Science, of course, demands more than curiosity. It demands data, repeatability, rigor, but it also requires questions. And some of the best questions start with outliers, with things that don't fit. Most anomalies turn out to be nothing significant, but a few lead somewhere genuinely new. So even if the tektites are just splash-form glass, and the tools are from known species, and the tall tales are just that, they still have a role to play. They remind us to look closer, to wonder what might have been missed, and to accept that the line between natural and artificial, between coincidence and pattern, isn't always obvious. Next, we'll step further into that uncertainty, because not every intelligent culture would have developed in the same way. Not every civilization would have chosen stone or metal, and if some never did, their remains, if they exist, might be so subtle we've already walked past them unnoticed, unmarked, but not entirely gone. When we picture a civilization, we tend to imagine certain things automatically: tools, buildings, machines, writing, monuments, and almost all of it made from or shaped by metal. It's foundational to how we define technological progress: the Stone Age, the Bronze Age, the Iron Age. But that framework assumes one particular path, one model, one ladder of development, and it's easy to forget that metal isn't actually a requirement for intelligence or even for remarkable complexity. It's just what we happen to use. So what if a different civilization never reached for it? What if it evolved, flourished, and vanished without ever needing to extract metal from rock? The idea isn't far-fetched at all. In fact, for most of our own species' history, we lived quite successfully without metal. Early humans crafted sophisticated stone tools, built with wood and bone, used fire, understood animal behavior, made clothing, decorated their homes, and developed rich oral traditions, all without smelting a single ounce of ore. Many indigenous cultures continue to thrive with limited or no metalwork, even after contact with those who did develop it. Complexity doesn't begin with metallurgy. It only becomes visible to archaeologists in certain ways because of it. So if we consider the possibility of a pre-human or non-human civilization, it's worth asking, what would their record look like if they never entered a metal age? The short answer is that it would be incredibly difficult to find, even if we knew where to look. Organic materials, wood, plant fiber, animal hide, even bone, decompose rapidly unless preserved in extremely dry, frozen, or anaerobic environments. Textiles rot completely, wood burns or decays, anything left exposed to moisture, heat, or biological activity breaks down quickly. Without stone or metal or ceramic to carry the memory of those objects forward, nothing stays put for long. And even when organic remains are preserved, they're rarely interpreted as technological unless they show obvious shaping or patterning. A bundle of fibers might be string, or it might be roots. A hollowed out log might be a canoe, or just a log. Now consider a hypothetical civilization that built entirely from biodegradable materials, shelters of woven plant fiber, tools made from hardwoods, containers from gourds or leather, decorations and clothing from natural pigments, feathers, bark, sand, smoke. Nothing mined, nothing smelted, nothing left to rust or fracture into durable fragments. In the right climate, that society could exist for thousands of years and leave behind almost nothing we'd recognize in the geological record. A forest could grow over it in a decade, erosion could take the rest, and in 1,000,000 years, not a trace would remain. Even fire, one of the oldest and most transformative technologies, doesn't preserve well over geological time. You can find charcoal layers, ash beds, fire-cracked rocks, but those are common in nature too. Lightning strikes, wildfires, volcanic activity all leave similar marks. Distinguishing a fire used by intelligence from one caused by natural forces requires context, hearths, patterns, associated artifacts. Without those, it's just another black layer in the soil. Some non-metal tools could survive, especially stone, but not all stone tools are obvious to identify. A pebble used to grind grain or soften fiber might never be deliberately shaped. A sharp rock used to cut might not be retouched or modified. If tools aren't curated, kept, stored, and reused, they blend into the natural background, and if they're used in ways that don't create lasting wear patterns, they're nearly impossible to identify after the fact. It's also possible a civilization could reach high levels of understanding, astronomy, agriculture, even medicine, without needing heavy industry. Knowledge isn't always tied to material excess. A society might map the stars with naked-eye observations, track seasons with stone or wooden markers, or breed plants through careful observation and selection. They might tell time with water, compute with knots or beads, pass down knowledge through encoded song. Nothing in those systems demands metal, only continuity, and if that continuity breaks, natural disaster, disease, migration, the knowledge can be lost just as quickly as the tools decay. As you settle deeper into these thoughts tonight, as your mind begins to slow and match the patient rhythm of geological time itself, I'm deeply curious about something. What kind of knowledge do you think might actually survive such vast spans of time? If you had to choose just one thing to preserve across millions and millions of years, one piece of wisdom, one discovery, one truth about existence, what would you want to ensure made it through to whatever intelligence might come after us? And I'm curious too about your own journey to this moment. What is it about these ancient mysteries that calls to you? Are you someone who often finds yourself wondering about the deep past as you drift off to sleep? Or perhaps you're discovering this kind of contemplation for the first time. Where in the world are you right now as you listen to these words? What does the night look like outside your window? What sounds are filling the air around you? Are you in a place where you can see stars, those same points of light that might have guided vanished civilizations to their own moments of understanding? Drop a gentle comment below and share whatever comes to mind, your thoughts about what might survive deep time, where you're listening from tonight, what time it is in your corner of the world, or simply what draws you to these quiet mysteries. There's something deeply moving about imagining these quiet, careful ways of knowing that might have existed and vanished without leaving any trace we could recognize. Reading your reflections and knowing that minds all over the planet are contemplating these same questions somehow makes the vastness of time feel a little less lonely, a little more connected. Language, especially, is fragile. Spoken words vanish with the speaker. If not written or carved, they disappear entirely. And even written records can fade. Paper burns, bark and leaves decay. Inscriptions in sand, dust, paint, or wood don't last unless intentionally preserved. So if a civilization never developed a durable script, or never needed one, we might never know it existed. And then there's the question of scale. Not all civilizations build cities. Some remain mobile. Some blend into their ecosystems so seamlessly that their presence might be nearly invisible, even to contemporary observers. Perhaps they lived in harmony with natural cycles, leaving footprints so light that time could erase them without effort. Perhaps they understood something about existence that we, with all our concrete and steel and permanent monuments, have forgotten entirely. Maybe they knew secrets about living sustainably, about reading the subtle signs in nature, about measuring time and tracking seasons in ways we've completely lost. If these quiet mysteries speak to you the way they speak to me, if you find yourself drawn to these gentle questions that have no urgent answers but somehow feel important to explore, I'd be genuinely grateful if you subscribed and let the notification bell carry more of these contemplative journeys to you whenever you need them. Think of it as joining a circle of fellow wanderers, people who understand that some of the most profound questions are also the most peaceful ones, who appreciate that not every mystery needs to be solved immediately or dramatically. Whether you listen to these explorations as you're falling asleep, or during quiet moments in your day when your mind craves something deeper than the usual noise, you'll always find new questions waiting here, new mysteries to contemplate at whatever pace feels right to you. There's no rush, no pressure, just the soft invitation to continue wondering together about the deep, patient mysteries that time keeps folded away in its layers, waiting for minds curious enough to ask what might have been. And so we arrive at the most beautiful uncertainty of all. We cannot know, we cannot prove, we can only wonder, with the same quiet curiosity that might have driven those hypothetical observers to map the stars or encode their knowledge in song. And sense of evidence is not evidence of absence, it's simply the natural state of deep time, which holds its secrets lightly and lets them go without ceremony. Somewhere in that vast, patient silence, perhaps other minds once pondered questions not so different from the ones that brought you here tonight. Perhaps they too wondered about their place in the long story of intelligence on this ancient world. Perhaps they too looked up at the same stars we see, asked the same questions we ask, and then quietly faded back into the earth that bore them, leaving nothing behind but the faintest echo of curiosity itself. Sweet dreams, fellow traveler through deep time. May your rest be filled with gentle questions and the peaceful certainty that wonder itself is enough, that the asking matters more than the answering, and that somewhere in the vast library of time, every question ever asked is somehow still echoing, still calling quietly to those who care to listen.